Welcome to the Explainer. Today, we are diving into a skill that's an absolute game changer for anyone learning to program, writing pseudocode. Think of it as the secret step that turns a fuzzy idea into a rock-solid plan. And today, we're going to learn how to do it perfectly.
You know that feeling, right? You've got this amazing idea, you fire up your code editor, you're ready to go, and then you just stare at the blinking cursor. Where do you even start? How do you get from that big picture in your head to actual working lines of code? Don't worry, it's a super common roadblock.
Well, it turns out there's a missing step. There's something you need to do between having the idea and writing the code. You need to create a blueprint, a map, just for the logic itself.
And that blueprint has a name: pseudocode. Its whole job is to let you write out the steps of your program using plain English without worrying about the strict rules of a programming language. No semicolons, no weird syntax, just pure, clear, human-readable logic.
So, how do we make sure our blueprint is actually clear and not just a messy sketch? It all comes down to 3 golden rules. These aren't suggestions, they're non-negotiable conventions that make sure anyone, including your future self, can understand your logic at a glance.
And here they are. It's pretty simple. 1, keywords go in all caps. 2, structure blocks always come in pairs, a beginning and an end. And 3, indentation isn't just for looks, it is absolutely mandatory. Let's dig into what each of these really means. Okay, rule number 1, keywords in caps. Any special word that controls the program's flow, we're talking words like if, then, while, and for, has to be in uppercase. This makes those commands just jump off the page. It instantly shows you the skeleton of your algorithm. Rule 2, paired blocks. Every single logical structure needs a clear start and a clear end. So if you open an if, you have to close it with an end if. If you start a while loop, you have to finish it with an end while. This creates these neat little containers for your logic, so you're never left scratching your head wondering where a block of code begins or ends. And finally, rule number 3. Mandatory indentation. Now this might be the most important of all. Anything that happens inside a block, like the code under an if statement, must be indented. It's how you visually show nesting and relationships. When you start getting loops inside of other loops, trust me, proper indentation is the only thing that keeps it from becoming a tangled mess.
All right, we've got the rules down. Now let's get to the fun part and actually build something. The first powerful tool we have is called selection, which is just a fancy word for decision-making. This is how we give our program a brain and let it make choices. And decision-making really comes in 2 main flavors. You've got binary selection, which is your basic yes or no, true or false choice, a single fork in the road. Then you have multi-way selection, which is what you use when there are several possible paths, like choosing small, medium, or large. So for that simple binary choice, we use the if, then, end if structure. See how it works here? We use if to ask the question, is the size large? If the answer is yes, then we do the action add 4 to the price. Then we close the whole thought with end if. It's a clean, self-contained little decision.
But what if you need more options? That's where else if becomes your best friend. Look at this. The program first checks if the size is medium. If it's not, it doesn't just give up. It moves on to the else if and asks a new question. Okay, well, is it large? Notice that beautiful indentation? It makes it super clear which action belongs to which choice. Next up, let's talk about one of the most powerful ideas in all of programming: repetition. Or, loops. Because when you need to do the same thing a bunch of times, you definitely don't want to write it out over and over again. You tell the computer to loop it.
Now, the main difference between loop types usually comes down to when the check happens. A pretest loop, like a while loop, is like a bouncer at a club. It checks the condition before letting you in. If the condition is false from the start, you don't even get to run the loop once. A post-test loop, on the other hand, lets you run the code at least once and then checks if it should do it again. A guessing game is the classic example of a pretest while loop. It's perfect. The logic is simple. While the user's guess is not equal to the secret number, keep asking them for another guess. The very moment they guess correctly, that condition becomes false and the loop just stops.
clean and efficient.
Okay, but what if you know exactly how many times you need to do something? Say you know you have an order for 5 pizzas. That's the perfect job for a for loop. You just tell it, for I equals 1 to the number of pizzas, do this thing. The loop takes care of all the counting for you. So we have our rules, we can make decisions, and we can repeat things. We have all the building blocks. Now, let's see how we use them to tackle bigger, more complex problems. The key is to break things down into smaller, bite-sized pieces called subroutines. Check this out. Our main program at the top is kept nice and simple. Instead of cluttering it up with all the pricing logic, it just makes a call to a helper. It says, hey, calculate pizza cost. Here's a pizza size and the number of toppings. Go figure out the price for me. That call then runs the second block of code, which does the work and uses the return keyword to send the answer back. This is called modularity, and it's how you keep big programs from becoming a nightmare. Now, that calculate pizza cost subroutine is a special kind called a function, and a function has a very specific job description. It's designed to do one thing and do it well. It takes in some data, we call those parameters, it does its work, and most importantly, it uses that return keyword to send a single value back to whoever asked. And really, that quote says it all. Everything we've talked about, the caps, the paired blocks, the indentation, all of it, it all serves this one simple goal: to describe your logic so clearly that any person can read it and understand the plan before you write a single line of real code. So there you have it, the rules, the structures, the entire strategy for turning your big ideas into clear, logical blueprints. You are totally ready to start designing algorithms with confidence. Thanks for tuning into The Explainer. Now I've got to ask, what will you design first?